Okay, today we talked about slopes of lines. So you're going to find the slopes of lines and then you're going to use slopes to determine whether you have parallel or perpendicular lines. Okay, rate of changes is just a review. This measures how much a quantity changes on average relative to the change in another quantity. When this concept is applied to points on a coordinate plane, we call it slope. And then there's lots of ways to define slope. We talked about this the other day. Slope is your change in your y coordinates over your change in your x coordinates, and we did like a delta y over a delta x. It's also known as rise over run, and then we can use the formula y1 minus y2 over x1 minus x2, or we can reverse that order, y2 minus y1 over x2 minus x1. There are 4 different kinds of slopes for linear equations. This is our positive slope, and it's when m is greater than 0. We can use the term rises to describe it. Here we have a negative slope, so our slope has to be less than 0. That means it's you can describe the line as falling. Here is a 0 slope when m equals 0, and you're going to get this if you have an equation where y equals some number. So like y equals 12, that is not a hashtag, and this occurs when you have a horizontal line. Our next one is a vertical line. This is when you have an undefined slope, and this will occur when you have slope. When you solve it, you'll get some number, whether it be 4 naught over 0, and we know that we can't divide by 0. And then you'll also get it when you have x equals some number. So for example, if you have x equals -3, then you'll get a line that looks like that. So example 1 says determine the slope of the line that contains the given points. So we're just going to use our slope formula and take our, remember this is x1, y1, x2, y2. We'll take our y2, 2, minus our y1. So that will become plus 2 because it's minus a negative, over x2 minus x1 minus a -3 becomes plus 3. And we get 4 halves, which reduces to 2. Parallel, these are lines that have the same slope but different y-intercepts. They're also lines that never cross or intersect, and they're lines that are the same distance apart. So if I ask for, we will be doing this later, but we're going to look to find the distance between those two lines, and at any point that distance will be the same. Perpendicular, these are lines that intersect at one point. So if I have a coordinate plane, they also have, this is important, negative reciprocal slopes, and they form a right angle. Here we can see, even on a coordinate plane, there's perpendicular lines. Or if I did graph lines on this, if I have this line, then this one could be perpendicular as long as it has a right angle there. And then, most importantly, we're going to talk about these slopes as being negative reciprocal slopes. And then one last thing is that the product, meaning if we multiply the slopes together from each of the lines, you get -1. On example 2, we're going to determine whether A, B, and CD are parallel, perpendicular, or neither. So to determine this, we have to find the slope of the two lines. So the slope of AB, we're going to take 7 minus a -5 plus 5 over 4 minus a -2 plus 2. And that gives us 12 over 6, which reduces to 2. The slope for CD, we take -2 minus 2 over 8 minus 0. So on the top you get -4 over 8. This reduces to -1/2. And we can see that these are negative reciprocals, so we would say that these two lines are perpendicular. And we can use the symbol, it's an upside down T, to represent perpendicular, or you can write the word perpendicular out. On B, we're doing the same thing, finding the slope of AB and the slope of CD, and then we'll compare them. For AB, we have -4 minus a -7, so plus 7, and 4 minus a -8 plus 8. Gives us 3 over 12. And this reduces to 1/4. For CD, we have 7 minus a -5 plus 5 over 1 minus a -2 plus 2. This gives us 12 over 3, which reduces to 4. Now these are not perpendicular because they are not negative reciprocals, and they are not parallel because they're not exactly the same. So in this case we would say that these lines are neither. What it does mean is that eventually if we graph these two lines that they will intersect at some point. On example 3, we're going to graph a line that contains a point and is perpendicular to JK. So I would graph JK first. So I have graphed this. I went back 5 down 4 and over 0 down 2 to graph JK. Then it says graph a line that is perpendicular to this but passes through -2, 1. So I need to pass through that point. What you can do is you can actually find the slope of JK, and you can use the formula that we just did, or you can go on your graph and count. It goes up 2 over 5. So if we want one that is perpendicular, a slope perpendicular would take the reciprocal and then change the sign. So I'm going to go ahead and go to this point P, and I'm going to apply that slope, which says we go down 5, forward 2. And that should create a line that is perpendicular to the other line. Now you're going to have other examples like this, but they're not going to ask you to do specifically perpendicular. They might ask you to do parallel lines. So good luck. Your assignment is 9-2, slopes of lines.